The topic of this video is finite geometric series. Now the word finite means to have a limit or a bound. And so basically we're looking at a geometric series, so a sum of a geometric sequence that we're going to stop at a specific term number. So meaning it's going to be finite. Okay. Now here is the formula for the summation of a geometric series that's finite, and there's a lot of components to it that we want to make sure that you understand. So first off, looking at the left-hand side of this formula, the S sub n means the sum of the first n terms. Now a sub 1 is just like a sub 1 with an arithmetic sequence or series, which means that it's the first term. Now r shows up twice within the formula, and it means the same in both locations, and it's what you are already familiar with as what r represents, and that's your common ratio, or what it is that you are multiplying by. The last thing within our formula is n, and n represents the number of terms within the sequence that we're wanting to add, add together. So this would typically be the number at the top of your summation notation that's telling you where to stop. So that is your finite geometric series formula with all of its components. Now, if you're using a technology tool such as a calculator to perform the math, best thing that you can do for yourself is to make sure that you're telling your calculator the correct order of operations. And so it wouldn't hurt to add an extra set of parentheses around your exponent, and then another extra set of parentheses around the entire numerator, just to make sure that you're giving your calculator the correct information so it knows the right order of operations to do. Now let's take a look at some examples of some finite geometric series, and we're going to go ahead and practice using that formula that we just previously were introduced to, so making sure that we know how to calculate this correctly. First things that we're going to want to start with is identifying what our a sub 1 is, our r, and our n. Knowing these three pieces of information will help us be able to plug it in to the formula. So let's go ahead and let's calculate our a sub 1. What that means is I'm going to take my argument, but this time I'm going to plug in 1 for that exponent, and therefore if I do the math correctly, this will equal 1.2. Now r, remember, is your common ratio, it's your multiplier, and this time it is 0.4 or 4/10, and n is the number of terms that I'm looking to add together. So to go from 1 to 6, so I'm starting at term 1 within the sequence, and I'm going to stop at term 6, so therefore that's going to be 6 terms within that sequence. Now I'm ready to go ahead and plug it into the formula. So up at the top, I just wanted to remind myself of what that formula looked like so I know where to correctly place my values. So I'm going to go ahead and start with my a sub 1, so that's 1.2 times 1 minus 0.4 raised to the 6th power, and I'm going to divide that by 1 minus 0.4. Now remember that we added those extra set of parentheses, so I'm going to go ahead and do that, so that way when I type it into my calculator, I can type it all in as one line. Now when I type this into my calculator, I get 1.9918. So hopefully if you typed it into your calculator or on Desmos, you got the same value as I did. Depending upon how your calculator is set up, it may have rounded this to 2 for the sum of this geometric sequence. Let's go ahead and look at this second example. Again, it's a geometric sequence that we're going to be looking at. So that because of the fact that we're looking at an explicit, I can see that I have term 0 multiplied by my common ratio. So we're going to go ahead and find the sum of that sequence, making this a series. So again, I'm going to use that same formula because I'm noticing that I'm stopping at term 10 and I'm starting at term 1. And then I can go ahead and start by finding my first term, my common ratio, and the number of terms that I'm going to be adding together. So a sub 1, r, and n. So a sub 1, again, is when I go ahead and plug in 1 in for that exponent, which then brings me to 12. R is my common ratio, which is going to be 2. And then n is going to be 10 in this case because I'm starting at 1 and I'm going to 10, so that'd be 10 terms that I'd want to add together to get this series. So I'm going to go ahead and take my values. Again, I'm going to plug it into the formula. Why don't you go ahead and pause this video and try it on your own and see if you get the same answer as I do. All right, going ahead and plugging it in. So I'm going to start off with my a sub 1, so my 12. I'm going to multiply that by 1 minus my common ratio, which is 2. This time it's going to be raised to the 10th power. And then I'm going to divide that by 1 minus 2. So when I put that into my calculator with its added parentheses, I end up with 12,276. Now here's another form of a geometric series. It's just written out, so we got to kind of look at and find some pieces in order to fit our formula. So the question states, find the sum, which is a summation, a series, of the first 5 terms, that's important, of the geometric sequence if a sub 2 is 8 and a sub 10 is 3. Now, what this is telling me is that the second term of my sequence is 8 and the third term of my sequence is 10. And I can use that information then to determine what my common ratio is. So that's a piece of information that's not given to me. And the other piece of information that's not given to me is my first term. So the only thing that I know of is right now is that I'm looking for the sum of the first 5 terms. So number of terms, or n, is going to be 5. So in order for me to work backwards to find my first term, I actually have to know my common ratio. So I'm going to go ahead and calculate that first by taking a sub 3 and dividing it by a sub 2. So if you have 2 consecutive terms within a sequence, you go ahead and divide them to be able to calculate the ratio. So I'm going to take 10 and divide it by 8, and that's going to leave me with 5/4, or 1.25 if you're looking at a decimal. All right, so now that I have my common ratio, I can actually work backwards to find my a sub 1. So to work backwards to do that, I'm going to take my second term, which is 8. I'm going to divide that by 1.25 just to be able to get my first term. And when I do that, I end up with 6.4. Now I have all the components that I need for that finite geometric series formula. I'm going to go ahead and remind myself of what that formula looks like, which is a sub 1 times 1 minus r to the nth power divided by 1 minus r. So again, I can go ahead and plug in my values. So I'm going to start off with 6.4 times 1 minus my common ratio, which is 1.25 raised to the 5th power, and then I'm going to divide that by 1 minus 1.25. Now again, it doesn't hurt to remind ourselves where the extra set of parentheses would need to go. I covered up one of them there, just so I can type it into my calculator on Desmos and end up with the correct value. So once I do all of that, my final sum equals 52.525. There's a decimal right there. So that would be the sum of this geometric sequence after calculating the first term, the common ratio, and then knowing how many terms within the sequence we're looking at finding the sum of. Here are some questions that I'd like you to try on your own, similar to what we were doing together in the first part of this video.